Morning,
ma'am.
morning.
Morning,
Okay,
ma'am.
very good.
Ma'am.
Can you clearly hear my voice?
Yes, ma'am.
Yes,
Yes, ma'am.
Okay, very good.
Ma'am.
Thank you. I will be checking the attendance anytime soon. We are already 40. I think you can already check the attendance. Okay. Ano ha? Wait lang. Um, Before anything else, let me check the attendance first. May I request you to turn on the camera, even just for the attendance. Today is. We will start from section Santol. If your name is called, please turn on the microphone and say present. Joshua. Anyosa. Arejan Edward. Mark Kenneth Bulanadi. Mark
present.
Kenneth. Okay, very good. Catalo Earl Joseph. Catalo.
Present.
Ilantar Earl.
Present.
Ilantar. Labro Andre, Lilia Renz Rodolph,
Present,
Lilia.
ma'am.
Very
Present.
good. Okay, very good. Rosalejos Hans Lomar, Rosalejos. Rosalejos. Absent, Rosalejos. Radel Samson. Radel.
Present.
Traboco John Ray. Traboco. John Ray. Abelia Princess. Adamas Kera. Adamas.
Present.
Very good. Alaya Francine. Alaya.
Present.
Amos Hannah.
Present.
Very good. Dennis Lorraine Apura. Dennis Lorraine. Banario Josel Faye.
Present.
Very good. Andrea Joy Beato. Andrea Joy.
Present.
Miska Cepeda. Miska Micaela Cepeda. Cecista Kiana.
Present.
Kiana. Doldolia. Jose Ray is a boy na hindi ko laihiyahan girls. Anyway, is Jose Ray around? Jose Ray. Marian Dulfo. Marian Dulfo. Christine Angeli. Christine. Denisa. Hyacinth Divine. Hyacinth. Tricia Gapud. Tricia. Angel Garcia. Angel. Liana Gura. Liana. Hazel Hilaria. Hazel. Shira Kirsty.
Present po.
Okay. Charnette Latoha.
Present.
Giselle Casey Mendoza. Giselle Casey. Montes Jahara. Montes. Padilla Jazil.
Present.
Isaiah Pagayanan. Isaiah May. Isaiah May.
Present.
Okay, very good. Allison May. Allison May. Yesa. Ninia Ramirez. Ramirez, Ninia. Cherise Dorothy Rijang. Cherise Dorothy. Grace Love Sabido. Grace Love.
Present. Present po.
Ella Turla.
Present po.
Very good. We go to section. I will be checking the attendance siguro mga after the discussion na. I will be checking the attendance for section Mango this time. Please say present once your name is called. Okay, 3. Who is 3, 24, 22. Zion Apita. Zion. Mark Pence Araba.
Present.
Mark Pence, very good. Chad Banadia.
Present.
Very good. John David Bantiles. John David. Justin Lay Bihar.
Present.
Justin Lay, very good. Lance Estrobo. Lance. Dick Juno. Ernst Tardillo. Eugenio Malinaw. Christian Andre Marasigan.
Present.
Alexi Nicart. Jade Ogale. Alexi, are you wearing your earphones or headset? Kasi gutit imo tingog. I think it would be better if you use a headset or an earphones. Ugale Jade. Jade. Carl Vincent. Yeshel Seso. Yeshel. San Emmanuel Solayaw.
Ma'am.
Present. Are you San? Emmanuel. Okay, very good. Mary Vincent. Uy. Mary Vincent. Erica Marie Aberia.
Present.
Lorraine Kim Abobo. Afabli Zoe.
Present.
Very good. Gail Alde. Gail Alde. Anna Gia Ambil.
Present po, ma'am.
Very
Gail
good.
Alder.
Okay, very good. Thank you. Raven Rose. Raven Rose. Are you around? Joyce Gale. Julia Apura.
Present po.
Julia. Very good.
Present.
Nash. Nash Astakaan. Okay, very
Present,
good.
ma'am.
Angeline Colima. Angeline. John Antoinette Tator.
Present.
Okay, very good. Krishna De Los Santos.
Present, ma'am.
Okay, very good. Gislaine Jolola. Gislaine.
Present po. Present po.
Okay. Liana Docena. Liana.
Present. Present po.
Okay. Jillian Gapate. Jillian. Julia Guevara.
Present po.
Julia. Okay, very good. Antoinette Labado.
Present.
Antoinette Lorraine. Maxian Marasigan.
Present.
How do you pronounce your name? Maxian or Maxian?
Makshan.
Okay, thank you. Debbie Annette Manson.
Present po.
Angel Monroy. Angel. Isabella Beralta.
Present, ma'am.
Isabella. Okay, very good. Francesca Daniel Promeda. Francesca Daniel. Jesslyn Faith Puno. Jesslyn Faith. Reese Sakmar.
Present po.
Okay, very good. Angelic Jin Suwal. Angelic Suwal. Okay. So the next checking of attendance will be after the discussion. Now, may I remind everyone to, especially those who are not yet done with the requirements for quarters 1 to 3, please feel free to submit it. Waray pa deadline. Waray pa deadline. Maset na laking deadline for these activities, for these required activities for quarters 1 to 3. Now, please make sure that you are complete with this before we start the face-to-face session. And I know you are all excited for this event. You are all excited to go to school. I think this is the very first time for most of you. This will be the very first time that you will see in person your classmates. Okay? It is not just you who is excited, but me as well. I am so excited to see you in person. I am so excited to discuss the topics in person. Okay, but before we go to that day, before we go to that very that very exciting day for all of us, actually I'm excited as you are. Please do the necessary things for you to be ready for the face-to-face classes. Okay? So, usang igre-require ko ha iyo before the face-to-face classes will be your lacking activities. There are still so many of you who still lack a number of activities. This is the very reason why I can't give you the grade, because I can't compute the grade that I want you to have. I know you deserve a very good grade. You deserve a very good grade only if that will only be realized if you will submit the required outputs. Okay? Can you promise me to do that, children? Yes or no?
Yes.
Yes.
Yes, ma'am. Yes, ma'am.
Yes. Kaya lang, most likely, in nga na, yes, ito mga kumpleto na, it may na mga grado. Ano waray pagad mga grado? Kasi, pag waray niyo grado, meaning to say, waray pahit. May ada pahit kulang. Mausala it nga activity, madamong activity, just the same. I cannot give you the grade because even if you just lack one activity, it means a lot. It really affects your grade. Imbis nga malaline of 9, danay na 85 la. I know you deserve a better grade. You deserve a better grade. Asa nga gin blablang ko kulaanay. I am patiently waiting for your outputs. Okay? So, our first day of classes, if it will be realized, our first day of classes will be on the 18th of April. 18th of April. So yan na, gimpapaprepare na kami. Gimpapaprepare na kami itong QR code. Kagabi nga ni, late na aki naturog kay nag-prepare akhan mga QR code an akon han section nara. It is actually my advisory class, section nara. So if your grades will be okay, definitely those who are section mango this time will be my advisory class next school year, God willing. Okay, so you will be with me again. And when classes will become normalized, I am handling also, aside from Biotech and grade 8, I am also handling Science 9. I am also handling Science 9. So, magkikita-kita pa rin tayo. Okay, hopefully, classes will become normalized next school year. Again, may I remind the students who are not yet complete with the required activities that I am asking from quarters 1 to 3, please submit it before face-to-face session starts. Okay, now, for quarter 3, I have noticed that there are still so many who have not yet passed the restriction enzyme activity. Remember, it is 32 points and all, 32 points and all. Ang mga haruhag bubuan ang score, ginpapaliwat ko because it will greatly affect your grade. Kasi masanin ka mo, hala, 90 man akatan una kay ano nga 86 na laakya na. Okay? Because of your outputs. Habubo pa nga ritong summative test, the more that you will decrease. But I don't want it to happen. As much as possible, i-increasean ko itong grade if you are not late in the submission of the required outputs. If you always submit outputs on time, definitely your grade will either be maintained or will be increased. Madepende liwat iton, ito yung grade, madepende liwat, of course, hiton iyo summative test result. Okay, now, today's topic, by the way, which is recombinant DNA technology, is quite important because this is actually an introduction for the quarter four topics. Quarter four topics. Kasi in quarter four, we will be dealing with the applications of biotechnology in the field of medicine, in the field of agriculture, in the field of the environment, and in the field of industry. Okay, parang what we will discuss today is an introduction of the topics that we will be discussing in the last quarter. Okay, so for those who are here, congratulations. Okay, because you will already have an idea of what we will discuss in the last quarter. Okay, in the face-to-face session. Okay, so our topic for today is recombinant DNA technology, which is the last module in quarter 3. You listen very well. This is quite short. I was then planning to give a summative test right after the discussion, pero banginder kita ig-awag kay danay nag-alas nagte 10 o'clock na nga ni and beyond na nahinay na itong internet. I don't know if you can observe that one. Didi kasi haamon nag-11 na nga ni or past 12 mahinay na itong internet or past 10 pala nga danay mahinay na itong internet. So I just reschedule it on a separate day. I think I can give it tomorrow. Okay, so we'll have the summative test for this topic tomorrow at 8 o'clock. Be there. Okay, so recombinant DNA technology. I think you already have an idea what recombinant DNA technology is all about. Anybody from the class who can give me or who can give an overview of what recombinant DNA technology is? Anybody? Volunteer from the Mango class. What for you is DNA technology? Recombinant DNA technology. Yes, Julola Giseline is raising her hand.
Recombinant DNA is the general name for taking a piece of one DNA and combining it with another strand of DNA.
Okay, very good. Another hand, yes, Antoinette Lavado. Antoinette is raising her hand. Just make it simple for everybody to understand. Just use simple terms. Do not use technical terms kay medyo mahihirapan ng iba. Okay, sige. Antoinette?
Recombinant DNA is a technology that uses enzymes to cut and paste together DNA sequences of interest.
Okay. Okay, thank you for that, Antoinette. One more hand. I want to see one more hand raised. Anybody from Section Santol this time? Section Santol? Anybody from your group? Anybody who wants to answer? Recombinant DNA technology. I think from the start, I have been mentioning recombinant DNA technology because this is the very core of genetic engineering. This is the very core of modern biotech, recombinant DNA technology. There is no recombinant DNA technology in traditional biotechnology. We can only have this. This can only be applied in modern biotech. Anybody from Section Santol, may I Ala, sige, matawag na lang ako ano. Min, iton tatawagon ko nga diri mabaton, it simply means waray not hiya dida, absent not hiya dida. Ano? So, may I call on Earl Dilantar? Do you have any idea what recombinant DNA technology is? Earl Dilantar? Okay, very good.
A recombinant DNA
Uh-huh.
technology is widely used in agriculture to produce genetic modified organisms.
Okay, so from the word itself, recombinant DNA technology, from the term itself, do you have any idea what it is all about?
Recombining DNA.
Okay, very good. Recombining DNA from
Wala na.
DNA, recombining DNA from, you started it right. Okay, you started it right. So recombinant DNA, recombine DNA from what sources? From, dapat may ada. Tikang ito niya diin nga imugin ko combine. So, combining DNA from, anybody who can continue the statement? Kasi direct pa hiya complete. Combine DNA from
Another DNA.
From another DNA, from, okay, second for that.
Times.
Molecules.
Another strand of
Molecules.
Combining DNA from molecules, another answer.
Enzyme.
Combining DNA from
Enzyme.
Another strand of DNA.
With another strand
from
of
another
DNA.
strand of DNA. Okay, so the
From
correct
genetic-
answer for that is combine the DNA from different sources, from two different sources. So let's take, for example, iplasmid. Remember that iplasmid is a circular DNA from, take ang DNA ya, iplasmid, class. From what organism? From what organism, class? Coming from, where can we find the plasmid? Anybody? This is the last one.
Bacteria. Bacteria.
Bacteria and other cells.
From, very good, from bacteria. Okay, so let's say, for example, a plasmid has, or you inserted a foreign DNA coming from a human cell or coming from a human DNA into a plasmid. That is recombinant DNA. Okay, so in recombinant DNA technology, this is actually a process wherein DNA from different sources are combined. So from the word recombinant, recombination. Okay, so that is an overview of what we will discuss today. Okay. Okay, so we'll move on. Okay, so I will read. Okay. I will read to you the introduction. You read it silently as I read the introduction to you. Not too long ago, using bacteria to produce human insulin and inserting genes into tomatoes and human cells were ideas that existed only in science fiction books and movies. Before it was just a dream, diba, class? But now, it is already realized. But now the techniques required to carry out these ideas have been developed and are used daily. Most of the tomatoes that we use in cooking, most of them are genetically modified. To date, more than 150 products produced by biotechnology are being used in medicine and agriculture. So in medicine, I think most of us are already vaccinated. So the vaccination that was introduced to our body, the vaccine that was introduced to our body, the vaccine that was injected to us are genetically or is a product or was a product of recombinant DNA technology, not only in medicine, but in agriculture as well. So another 100 and more new products are in various stages of development. So you can see that biotechnology may soon influence your life more than any other technology will. As you read on, you will discover some of the other contributions of biotechnology. Scientists use biotechnology in much more sophisticated ways today. Scientists can actually use microorganisms to make many biologically important substances. For example, most genetic research is done at the molecular level. Scientists are now able to manipulate genes of living organisms. This technique is usually called genetic engineering. In other words, recombinant DNA technology is also called as genetic engineering. Genetic engineering. Engineering means manipulation. So engineering of the genes or manipulation of the genes is the very core of modern biotechnology, as what I have said just a while ago. Many times, genes are actually moved from one DNA molecule and inserted into another. Again, genes are actually moved from one DNA molecule and inserted into another. The new DNA molecule is then called recombinant DNA. Okay, so a DNA from which a foreign DNA is inserted into it is called as a recombinant DNA. Actually, there is another term for this, which we will discuss later. In this module, we will give you the idea on how recombinant DNA technology improves life and gives a unique impact in bringing advancement in human life and playing a vital role in improving health conditions. Okay, actually in Q4, DNA technology is not just applied in improving health conditions, in the advancement of human life, but in many fields as well, in agriculture, in the environment, as well as in industry. So the competency for this topic is to outline the main steps in recombinant DNA technology. This is actually the highlight for today's discussion. Outline the main steps in recombinant DNA technology, which will be assessed tomorrow. So the lessons are arranged to follow the standard sequence of the course. This module is divided into 3 lessons. Lesson 1 is recombinant DNA technology defined. Lesson 2, actually, I have already given you an overview of the recombinant DNA technology. Now, lesson 2 deals with steps in recombinant DNA technology, and in lesson 3 deals with the applications of rDNA technology, which is, again, is what I have said just a while ago, which will be discussed in detail in Q4. Okay, so these are the 3 lessons that we will discuss for today's meeting. Lesson 1 for recombinant DNA technology, defined. Lesson 2 for the steps in recombinant DNA technology, and lesson 3 for the applications of recombinant DNA technology. After going through this module, you are expected to. So we will be guided with the following objectives. First, explain recombinant DNA technology. Again, after going through this module, after the discussion, you are expected to explain recombinant DNA technology. You are expected to name special tools used in recombinant DNA technology. I think you already have an idea for this because this was already discussed in module 1. After going through this module, you are also expected to summarize the steps and protocol involved in recombinant DNA technology. This is, again, the highlight for today's discussion. After going through this module, you are expected to construct a model that can be used to explore the process of our DNA technology. I hope you still have the hard copy of the activity. So this is one of the last 2 activities that you will submit for quarter 3. And after going through this module, you are expected to determine the different applications of our DNA technology. I think this is the last one of the last 2 activities that you will submit. Okay. So 4 and 5 are activity based. You will do this after the discussion. You will submit it after the discussion. You can submit it next week or during the retrieval or the schedule of the retrieval in your barangay. Okay? Okay. So for the review, last time for quarter 1 or in quarter 1 in module 1, in quarter 3 module 1, we discussed on the different tools used in recombinant DNA technology. Who can give me the different tools used in modern biotech or in genetic engineering? Give me one. Justin Lay. Is Justin Lay still around? Malinaw. The 4th. May I hear from you? Okay, give me one. We are still reviewing. Give me one of the different tools, just one tool used in genetic engineering. The 4th, do you have an idea? We go to Mark Kenneth. Mark Kenneth, can you give one tool in genetic engineering? This will, tool. I am asking a tool. Parang mag-garden kita, nagamit kita bolo, nagamit kita mga garden tools like bolo, like what else? Gloves. Okay, so those are the tools in gardening. So in genetic engineering, since this is a process, tools are also very important. Tools are used to do the process. And may I then ask Raydel Samson, do you have an idea, Raydel? Raydel.
Ano po?
Same question, Radel. Radel, wari ko papamati. Ano po po, no? Okay. So, Isabella, do you have an idea? Give me one tool used in genetic engineering or recombinant DNA technology. As what I've said just a while ago, recombinant DNA technology is also known as genetic engineering. Genetic engineering. Aliana, Docena. Aliana.
Polymerase chain reaction, ma'am.
Again.
Polymerase chain reaction.
Polymerase chain reaction. Okay, so that is one of the tools in genetic engineering. Thank you for that, Aliana. Another answer from Makshan Marasigan. Makshan Marasigan. Ada pa yung Makshan? Nalawarin na ada din.
Yes, mo, di pa.
Okay, sige. Can you give us one tool used in recombinant DNA technology? We discussed that before. May I call on Isaiah Pagayanan? Isaiah?
Plasmids.
Again?
Plasmids.
Plasmids, very good. Thank you for that. Plasmids. So aside from plasmids, can you name another or other vectors aside from plasmid? Plasmid is a vector used in genetic engineering. So aside from plasmid, other vectors that we can use in recombinant DNA technology or in genetic engineering, REEs. Aside from plasmid, can you name another vector?
DNA
Vector is
ligase.
one of, yes?
DNA ligase.
Ligase is not a vector. It is an
Plasmid.
enzyme. I think plasmid is already given. We cited, I think, a number of vectors used in genetic engineering. So plasmid is the most common one. But we can only use it when we insert a smaller fragments of DNA molecule. Smaller fragment. So kung nagamit na nga ni kita, medyo dako ng DNA molecule, plasmid is not anymore used. But a vector that can accommodate large molecules, large DNA fragments, rather. So Aliana is... Okay, Aliana was already mentioned. Sam Emmanuel. San Emmanuel, do you have an idea? Krishna, Jamel, Jillian, Kuya, ino kamu?
Restriction enzymes or molecular
Restriction enzymes, very good. Who answered that? So restriction enzymes are very important in recombinant DNA technology. Ano ang gamit pa daw ang restriction enzymes? Jillian?
DNAs into smaller fragments.
Ano ang gamitan restriction enzymes? They
cut DNA into smaller
very
fragments.
good. They cut DNA into smaller fragments. Duduha lang nga klasin cut, duduha lang nga paagihin cut, itira ginihimo. It can either be sticky ends or ano?
Or blunt.
Ends. Very good. So sticky or blunt ends. Now, in recombinant DNA technology, of course, you don't use You don't use scissors. You don't use scalpel. You don't use knives to cut the DNA molecule. Instead, restriction enzymes are used to cut the DNA into smaller fragments. So for the tools, restriction enzymes are mentioned or is mentioned. We have plasmids or the vectors, the PCR to make the process faster. What else? 3 are already mentioned. Another tool. So other tools that we can use in recombinant DNA technology.
Prokaryotic host.
I think Mart Bolanadi mentioned, did you mention gel electrophoresis? Mart Kenneth?
Waray pa po.
Ano mo na rin mo mention? Parang it was a I thought it was gel electrophoresis. Gel electrophoresis is also used in genetic engineering, aside from the PCR. Okay. For the enzymes, aside from restriction enzymes, ligases are also used. Ligases. Pero ligase is used only to ano't gamit? Once you cut and insert it, once you cut the DNA and insert it into another DNA, you need a ligase for this. Ano ang gamit ng ligase, Christian Andre? Christian Andre. So what is the purpose of using ligases or DNA ligase in recombinant DNA technology or genetic engineering? Amos? Hana? Ano ang gamit ng ligase, Amos? Hana? Grace Love, what do you think is the use of ligase or the function of ligase in genetic engineering? Grace Love?
To join together fragments.
Okay, very good. To join together the fragments para direhiya magburublag, dapat ipipaste. So genetic engineering is actually cut and paste. Dari copy paste, cut and paste method. You got the DNA and the cut portion or the fragment is inserted into another DNA and then pasted using the DNA ligase. So those are just a few of the different tools that are used in genetic engineering. And we discussed this during quarter 3, module 1. Okay. So we go to lesson 1 this time. Recombinant DNA technology defined. Okay. So what is DNA? I think we all know what DNA is. DNA. So deoxyribonucleic acid, which is found in, where can we find it? Where can we find the DNA? Erica, bangin man lang may ada pa di maarap kung hain itong DNA. Where can we find the DNA, Erica? Yes, Ana Gia?
In the cell nucleus.
In the nucleus of the cell. Very good. So it is the one that carries the genetic information that is transmitted from generation to generation. It is in the DNA where we can find the very important proteins for the survival of the cell and the organism as a whole. Okay? Okay, so DNA is a double helix that serves as the genetic material of all cellular organisms. Though RNA carries out that role for many viruses, the work of earlier scientists. Okay, so as said, DNA is the genetic, as what I've said before, DNA is the genetic material of most organisms. Most organisms. Most organisms, although there are organisms just like the live viruses, there are certain species of viruses that don't use DNA as their genetic material. Instead, they use RNA as their genetic material to carry out the role of the DNA. Okay, so now that you know what DNA is, what about recombinant DNA, which is also referred as gene splicing or rDNA technology? R for recombinant. Okay, recombinant DNA is also referred as gene splicing. Kaya ano nga gene splicing here, class? You know what splicing is? Splice. To splice means to splice means to, ano pag splice?
Cut.
Very good. To splice means to cut. So in genetic engineering or in recombinant DNA technology, desired genes in the DNA are being spliced. Desired genes in the DNA are being cut and transferred into another DNA. We also refer recombinant DNA as rDNA technology. Gin-shorten la hiya. R for recombinant. Okay. Recombinant DNA is the general name for taking a piece of one DNA and combining it with another strand of DNA. Taking a piece of one DNA and combining it with another strand of DNA. In other words, it takes two different cells to do the process. Okay? It takes two different cells to do the process. Cells of different organisms, to be specific. So you take one piece of one DNA from one cell and combine it with another strand of DNA in another cell. Thus, the name recombinant. From the word combine, gintampo ang magkaiba nga DNA. Siya nga recombinant DNA. This process produces new nucleotide sequence of arrangement. So of course, kay nagbutang ka naman hinbag-o nga strand, definitely the arrangement of the sequence in the DNA where you inserted the foreign DNA will be rearranged. That will be the sequence rather of the arrangement will be changed. Okay, so in recombinant DNA technology, a new nucleotide sequence of arrangements will be made. Okay, please take note of this. This might come out in the true or false test tomorrow. Mopay kung nahatag akin true or false kay nakakaghuna-huna ka mo. Gina-analyze niyo itong sentence. Kay in most cases, nakanotice ako, though I still can give identification or multiple choice, sus, danay ka mo nagpipinanalapang na. Okay, danay naman bibiling niyo answer that module, which is already cheating. Anyway, so tomorrow, by the way, please expect a true or false questions. Recombinant DNA molecules Recombinant DNA molecules are DNA molecules formed by laboratory methods of genetic recombination, such as molecular cloning, to bring together genetic material from multiple sources, creating sequences that would not otherwise be found in the genome. Now, please take note of this. The process, itong proseso, or when you do recombinant DNA technology, the process is done in the laboratory. It is done in the laboratory. In other words, the technology is done outside an organism. It is done outside. Dire iton ada mismo hiton organism. Mas ngala operahan ko inihiya, bubus-bus ang ano makuha ka dida mismo hiton iya cells, ada ako magmamanipulate hiton iya DNA. No. The process or the method is definitely done outside the body of the organism or outside the organism. Where is it done? In the laboratory. So it is done in the laboratory. Makuha kalahin cell, tapos do it outside the organism, outside the body. Makuha kahin plasmid or any vector, dida han organism. Okay? In other words, combination of the genes, combination of the DNA is done outside the organisms. It is done in the laboratory. Okay? Asya nga itong recombinant DNA technology starts at the cellular level. Kay ano? It ginmamanipulate is not the organism itself, but the cell of that organism. Okay? Cell. Asya nga, again, I would like to emphasize this one, recombinant DNA technology, which is done in the laboratory, starts at the cellular level. The process is not done in the organism itself. It is done in the laboratory, and it is done at the cellular level. So recombinant DNA molecules are DNA molecules formed by laboratory methods of genetic. Okay, so I'm done with this. It is a technique used in genetic engineering that involves the identification, isolation, and insertion of gene of interest into a vector. So I am already giving you an overview of the process, how or the steps on how the process is done. Okay. Anyway, we will discuss this in detail later. So it is a technique used in genetic engineering that involves the identification, isolation, and insertion of gene of interest into a vector such as a plasmid or bacteriophage to form a recombinant DNA molecule and production of large quantities of that gene fragment or product encoded by that gene. Asya nga nagamit nahin PCR and gel electrophoresis. Those are actually machines used in genetic engineering. The beginning of recombinant DNA techniques has provided scientists with a new tool to address the problems of gene structure, genetic function, and genome regulation. Okay, so more on our DNA technology defined. So as what I have said just a while ago, the recombinant DNA technology comprises altering or changing the genetic material outside an organism. In other words, the process is done in the laboratory. What is the purpose of doing this? To obtain enhanced and desired characteristics in living organisms or their products. So itong main objective, while scientists do recombinant DNA technology, is for them to obtain enhanced living organisms or living organisms with better characteristics or living organisms with better traits, better genes or better traits, or desired genes or desired characteristics, not only to the living organisms, but to their products as well. Okay? So, nagiging nutritious and more nutritious ang mga fruits and vegetables, or nagiging dagko ang mga fruits and vegetables because of the application of recombinant DNA technology into a certain plant. Okay, so recombinant DNA technology also involves the insertion of DNA fragments from a variety of sources, meaning damo itong pinankukuhaan, mapili ka, ano nga organism itong imukukuhaan. Just make sure that the organisms that, or where you will get the genes have desirable gene sequence. And you will insert it into an appropriate vector. It can be a plasmid, it can be a bacteriophage, it can be a plasmid of a bacterium, or it can be a capsid of a bacteriophage. Okay. Now, recombinant DNA technology, please take note of this. Recombinant DNA technology is also defined as the manipulation. So, maring manipulation, ginmamaniobra mo. You do something into the DNA of the cell of that organism, into the DNA of that organism. So, manipulation in organism's genome, which is carried out either through the introduction of one or more desirable genes or desirable genes. Pwede ka mag-introduce in the recombinant DNA technology. Pwede ka mag-introduce, meaning to say, pwede ka mag-insert in desirable genes into the DNA of another cell, or aside from introduction, aside from insertion, you can also decrease or block the expression of certain genes in that DNA. Masaring kunta, hala, inihiya nga gene, wala ko ang pulot, inihiya, rare na inihiya nga organism, kaya lang may ada niya mga genes that there are so many bad genes, or there is a bad gene in this DNA of this rare organism. So itong bubuhaton, i-block mo itong expression, or tatanggalan mo itong nga gene para dire na mag-manifest di dahiton nga organism, or i-block mo itong nga gene para dire na hiya ma-express di dahiton nga organism. Okay. So again, in recombinant DNA technology, we don't only insert foreign genes, we can also decrease or eliminate bad genes or block the expression of certain genes. Okay, so that is recombinant DNA technology. Now we go to the goals of recombinant DNA technology: to isolate and characterize a gene. Isolate and characterize a gene. Na ano pag-isolate? Kung mag-isolate ka, ginaano, nag-aano, or ginaano, sigunda kin-isolate ka. or nag-isolate ka, what do you do? Gin,
Remove.
ano hiya?
Separate.
Gin-remove, ginbubulag, o
Separate.
gin-separate
Separate po.
laanay. Ginbubulag laanay hiya. So to isolate means, when you isolate, it means you will cut a certain fragment and then you will remove a certain fragment and separate it from the other genes. So you isolate. Isolate and characterize a gene. So it imo isolate, meaning it imo tatanggalon tapos ibubulag, definitely it is a desired gene or a gene of interest, or it can be a gene with very good characteristic. Kaya tanggal mo hiya, tapos i-insert mo sa nga gene, meaning, most likely, that gene, that desired gene, has a very good characteristic. Okay, so one goal of recombinant DNA technology is to isolate and characterize a gene. Another is to make desired alterations in one or more isolated genes. Make desired alterations in one or more isolated genes. Nag-cut ka. Okay? I-change mo na ang gene. You make some alterations, you make some changes. Kasi syempre, mag-add ka na nga ni, nag-alter ka na. Meaning, manipulate mo na hiya. Altered gene na hiya, meaning changed gene. Ano ang alterations? It must be desired, inserting desired genes with good characteristics. Okay. Another goal is to return altered genes to living cells. Once altered, once changed na hiya, these genes will then be, the altered genes will then be inserted into a living cell. Masan ka, ma'am, ang kinuhaan goat, ibabalik ya diretso ha goat, asya ba? Ma'am, ang kinuhaan human cell, let's say for example, insulin, ma'am, ibabalik ba hiyang nga to ha tawo diretso? Yes or no?
No.
No, very good. So ikakainman hiya. Kung diriya ibabalik ka goat, kung diriya ibabalik diretso ngadto ha plant, kung diriya ibabalik diretso ngadto ha human organism, ikakainman hiya. Kasi ibabalik ko hiya ngadto a living cell. Very good. It will be inserted into a vector. The vector can be
Plasmids,
bacteriophage,
cosmids.
So kung plasmid, ibabalik hiya nga to bacteria. Ibabalik ba? Ito. Plasmid is not a living cell. It is just part of a living cell. So ibabalik hiya nga to bacteria para ini nga plasmid with the foreign gene in it will multiply. Okay? And will go on living also kay makuha man niya food from the living host. Okay? So another goal is artificially synthesize new gene. Artificially synthesize new gene. So parang adilain hiya the desired alterations. So pag-synthesize, paghimo, you are manually doing it. Alternating the genome of an organism. Another goal is alternating the genome of an organism. Alternating or altering, I think this is altering the genome of an organism. So change mo ang bugos nga DNA of that organism. Now when we say genome is the totality of all genes in an organism. genes are found in the DNA. So gin-alter mo ang bugos nga DNA. They're alternating ha, altering. So gina-alter mo, gin-change mo ang bugos nga genome. Meaning, it is not the old DNA anymore, but a new one. Okay, but a new one. Meaning may ada na niya inserted foreign gene or inserted gene of interest that you would like to be expressed in the next generation of that organism. So another goal is understanding the hereditary diseases and their cure. Another goal of recombinant DNA technology is understanding the hereditary diseases and their cure. Pag-aad man, iton nga organism, ano an iya mga hereditary diseases, ano iton mga diseases that can be passed on to the next generation. Masing ko wala mapapasa hiya. Pag-i-studyhan naman iton hiyang hereditary diseases, how to cure it. So, paano hiya tatambalon? Mismo didahiton nga gene, didahiton nga DNA. Okay, masan kunta, may ada ni hereditary disease. So, nga hereditary disease, namamana nga disease. Meaning, the disease is passed on from parent to offspring, from parents to children, or from generation to generation. Pag-aad man ito ng mga hereditary diseases. Tapos, paano hiya tatambalon? Okay? So, another goal in recombinant DNA technology is improving human genome. Improving human genome. Let's say, for example, in the genome of that person, may ada niya mga bad genes, or may ada niya, mga bad genes can be hereditary diseases. Pwede iton hiya tanggalon para iton hiya nga gene dire na mapasa, dire na mamana iton mga anak. Okay, that is one way of improving human genome. Okay? Blocking, removing, or inserting a desired gene of interest. Okay, so those are the goals of recombinant DNA technology. So we mentioned the tools just a while ago. So the tools used in recombinant DNA technology, i-repeat na naman natin. These are the enzymes, the nucleases, restriction enzymes. Okay. So the nucleases that cut DNA into fragments, and the ligases that join together the cut DNA fragments covalently. Okay, so aside from the enzymes, we have the vectors, we have the hosts, we have the DNA to be cloned. So these are the tools used in recombinant DNA technology. I will not explain this in detail anymore because this was already discussed in Module 1. Okay, so the 4 principal terms to understand gene splicing. I think you already know this. Plasmids, restriction enzymes. Do I need to repeat this, class? Basahan na lang niyo. This was already discussed in Module 1. Nagsummative test na nga ni kita, and many of you got a better result from this test. Okay, so questions on lesson 1. Definition of recombinant DNA technology. Questions? Anahan, dali lang. Okay, I'm back. Now, questions? Are there still questions in the definition of recombinant DNA technology? Children, are you still there?
Yes.
Yes, ma'am.
Ano, may ada pa niyo pakiana before we move to the next lesson. We're done with lesson 1, recombinant DNA technology defined. Are there still questions?
Wala na po.
Wala na. Thank you for that. Bangin man lahit siya dan sinarang. Wala na. What about the others? Hala, may I see some raised hands kung waray na pakiana so that we can move on to the next lesson. Okay. Okay, so I can see some 14, 16, 17, 18, 20, 21, 23, 24, 25, 26, 28. Kahit iba, may papakian na 29. We are 43 in all. May ada pa ba pakian na hit iba? Bangin at iba po rin na dida. Pero adi pa, 43 pa. Anyway, so, for those who still have questions, kasi damo na iton, okay na, just read module 1. We already discussed this one. Okay, so we go to lesson 2. Lesson 2 is the highlight of today's discussion. How is recombinant DNA technology done? So we'll discuss in this lesson the steps and protocol of recombinant DNA. Steps in recombinant DNA technology. Okay, are you ready for this? Please be ready with your pen and paper. We'll be discussing this time the different steps in recombinant DNA technology. The steps and protocol of recombinant DNA. Number 1 is identification and isolation of gene of interest or DNA fragment to be cloned. Identification and isolation of gene of interest. So the first step in our DNA technology is to isolate the desired DNA in its pure form, free from other macromolecules. Pareho mapalit kahin pet, or pareho mapalit kahin tanong, or didahan imo kasin may nag-anak nga dog. Karuyag mo mag-aro. Ano't imo bubuhaton. Igun tabay ada 10 puppies. Ano't first nga bubuhaton. Erica Marie. Igun ta didan imo neighbor near imo anyaw may ada nag-anak nga dog tapos may ada niya 10 puppies anak kada. So karuyag mo mag-aro. Imo mga pet dog or pet puppy. So what is the first thing that you will do, Erica Marie?
Papili.
Very good. Papili ka. Nay, alam nga naman, alabis na latano dida. Ang kuha na may ito. Kanan, mga desperado. So mapili ka. The more if you are given the chance to choose. Mapili ka, anay. Siyempre, itong imo pipilion, ano, Erica?
Pinaka-cute.
Pinaka-cute. Kung magpipili ka itong pinaka-cute, ano iton imo kikitaon din iton nga cute nga puppy?
Ikia color.
4. Ano pa? Kasi may ada, ako, I for one, na diri akin kuan itong nga damot buhok na dira ako itong kay madali pagkutuon na dira ako tapos naglalagas, so as much as possible karayag ko iton hair lang nga napilit lang that skin. I like those dogs na may ada sa ganito ng klaseng hair. So okay, so the hair, the type of hair or the texture of the hair, kasi may ada curly, may ada what else, cute na puppy, ano't ada itong cute na puppy hair.
Mabilis.
Ano pa?
Healthy.
Healthy, very good. So mapili ka, hindi na't matamo kay diri ipaprihot kadag o hiton papi, di ba? Iton origin na pulo iton anak. May ada hiton magasa, may ada matambok, may ada di medium la iton iya size. So pagpili ka natural, pipilion mo the healthiest. Nalang ko na muna audit masakiton, di ba? Tsura pala niya, karon masakiton na, definitely, you will not go for it. You will not opt selecting it. So, healthy. Ano pa? Liana. Kita may, di papapili kayong puppy na cute. Arot aadahit nga cute na puppy aside from being healthy, aside from having good hair, good quality hair. What else?
Personality.
Personality, dog.
Playful.
Iti personality. Playful. Okay. Oo, may ada. Kasi sigunta mga kuan na mga tag 2 months na hiya, no? Or 1 month or 2 months. So makikita mo na itong playful. Playful nga ni, healthy itong hiya. What else? What about the color? Are you attracted with colors of dogs?
No. Yes.
Yes.
Di ba?
Yes.
Kasi kaada lakit golden retriever kay maupay iya color. Or ada lakit husky nga white na direct iton po ang punta, black and white, ada lakit white na husky with blue hair. With blue eyes rather. White na husky with kay meda namon kasi did never iton era husky. Dabot era husky tapos may ada nira husky nga blue-eyed na white color. Cute here. So what else?
Their breed.
Their breed. Okay. So kung usala nga nag-anak, di ka na makakagpili kay paprano itong breed. Dire masing ka mapakianak ka. Hiro tatay hini, bangin naman lahas kanya tatay or golden retriever or ano tila. Anyway, now. So the first step in recombinant DNA technology is just like the first step that you will do when you choose a puppy that you will use as a pet. Pipiliin mo. Paano ka magpipili? You must look for the desired characteristics that that will be expressed in that organism. Okay? After identifying the gene of interest, after identifying the desired characteristics that you want to have, isolate that gene of interest. Let's take, for example, karuyag mo hin blue ga color for a certain flower or a flower of a certain plant. I-identify mo ang gene bearing blue color. Then, isolate it from the other genes. Okay? Nakukuha niyo? So,
Yes.
did itong gene, did itong DNA, di ba itong DNA? DNA is rather made up of many genes. The genes of an organism are found rather in the DNA of the nucleus. So, whatever desired characteristics that you would like for the organism that you would like it to be expressed in that organism. Pangingitaon mo ito niya, you must identify it in that DNA. After identifying the genes of interest, or after identifying the desired genes, isolate those genes. I-isolate mo hiya. Okay? Musala, isolate the gene of interest. Isolate the desired gene. That will be the very first step that you will do. Okay? So the first step is to identify and then isolate. After identification, isolate the desired gene. Isolate the gene of interest or isolate the DNA fragment that you have just identified. And be ready to clone it. So that gene of interest, definitely, ipadadamuon mo ito niya. Kay kung usala, dere mo ito niya padamuon, stop mo until there, wala usa man lang niya nga, dapat padadamuon mo niya. Most likely, you will not become successful in that process. Okay? So next step. So adi na kita ha, isolation of the desired gene. Isolation of the desired gene. Okay? Gintanggal mo na hiya dida, kunta ini, ang DNA, yala pa dada kunta. Okay, ini ang DNA. Gintanggal mo na hiya dida, han organism, didahan cell, han organism. Then, look for the desired gene. Ini kunta hiya. You will tanggalize this one. You will remove this one and isolate it. Again, after identifying this gene, as any desired gene, remove it, then isolate it. Wow. Okay, that is the very first step. Next. Number 2 is insertion of this isolated gene into a suitable vector. Nag-identify ka na, ginbulag mo na hiya, han kadaman, ginbulag mo na hiya, didahan DNA, then insertion of isolated vector. Isolated vector. Ano na ito hiya? Okay, so, by the way, first and foremost, remove the DNA from the cell. Remove a plasmid from the host. Okay? Okay. Through restriction enzymes, cut the desired gene. Through same restriction enzyme, cut the plasmid. Nakukuha niyo? Kung sticky dida, let's say for example, ang ginamit, echo R1, ang ginamit pagkathan plasmid, echo R1 gihapon, it gagamiton, dida hiton, dida hiton, what's this? Pharyngene. Pagkatitan pharyngene. Okay? Okay. And then, so isolate the vector. So when isolate ko na vector, then, alam na sunod. Okay. So number 2, again, insertion of this, ano nga naghimuhin na module? Insertion of this isolated, okay. Insertion of this isolated gene into a suitable vector. So insertion of the isolated gene into the plasmid. Plasmid being the vector. Kung an imo vector is a bacteriophage, then you will insert this isolated gene into the bacteriophage. Okay? Kung an imo ginamit yeast, then you will insert this into the vector, which is the yeast. Okay. Next. Okay, so these are the vectors that you can use in recombinant DNA technology. It can be a plasmid, a bacteriophage, a cosmid, a BEC, a yeast vector, a shuttle vector. So next. Number 3 is formation of chimeric DNA. As an ring, recombinant DNA, a DNA which has a foreign DNA inserted into it is called as recombinant DNA molecule. You can also call it as a hybrid molecule or a hybrid DNA molecule. And you can also call it as a chimeric DNA. Paprehula ito nit irakaryag sidngon. Chimeric DNA, hybrid DNA, or recombinant DNA molecule. They all mean the same. Now, what do we mean by chimeric DNA or hybrid DNA or recombinant DNA? Ano pa doon iyakaryag sidngon? Ano pa doon taniya meaning? Jazel, Padilla. So sa meringani, chimeric DNA, para sa itong tiyakarag sigurno hybrid DNA or recombinant DNA molecule. So I think I mentioned already recombinant DNA molecule. Ano pa doon itong correct sigurno? Chad, are you there? Chad? Okay, so what do we mean by chimeric DNA, which we also call as recombinant DNA molecule? What do we mean by this? Chimeric DNA.
Modified na po nga DNA.
Very good.
Yung combined po from different sources through
Very
tapos naman
good.
po ikakadahin mga vectors para nga dahil post.
Okay. So meron nga ni, okay, thank you for that, Chad. Your answer was correct. So meron nga ni chimeric DNA, meaning combined DNA na hiya. DNA with a foreign gene inserted into it. Ano, itawag ita iya chimeric DNA, which we also call as hybrid DNA. Hybrid kay ano? Hybrid, meaning may ada niya foreign genes. Recombinant DNA, meaning to say combined DNA na hiya. Okay. Chimeric DNA. So, the third step is formation of chimeric DNA or formation of hybrid DNA or formation of recombinant DNA molecule. Okay? Paano hiya mahihimo nga chimeric DNA? You simply insert the DNA that you identified and isolated into the plasmid. What you will have now is the recombinant DNA molecule or a recombinant plasmid or a chimeric DNA or a chimeric plasmid. Kasi plasmid DNA man la ito niya actually. Okay? Okay na, number 4. Okay. Paano? How will you do it? How will you form a chimeric DNA? How will you make chimeric DNA? You can use physical transport methods using electroporation, using microinjection, and all of this. Okay, actually, and na-mention ko latanad to during module 1 discussion, electroporation, microinjection. Okay, Pero itong pinakasimple, you can use transformation technique. Transformation. So, ikukuan lahiya, inihiya nga DNA, isolated DNA or isolated gene, ipapajoin mo lahiya nga da hiton plasmid in a natural way. Okay? We call that process as transformation. Okay? Kasi ang transduction, hindi hiya nga chimeric DNA makadto na hiya ha bacterium. That is transduction. Kung an isolated DNA, ikakada pala hiya ha plasmid in a natural way, we call it as transformation. Kung ang chimeric DNA, ikakadto na ha bacterium in a natural way, we call it as transduction. Okay? So aside from the natural process, we can also transfer isolated genes physically using some techniques like electroporation, microinjection, nuclear gun. Okay, di ba? And did mention na mga, I don't know if you still remember the some of the tests that we had. I don't know if you still remember module 1 discussion. So asa ito hiya ang mga physical gene transport. So if you want to make it fast, if you don't want the natural process, you can use other tools to hasten the process. Okay. Uptake. Number 4 is uptake of chimeric DNA transfection. Or kanina, nag-mention ang transductions. Paras lateral. So uptake of chimeric DNA. Uptake of chimeric DNA, the chimeric DNA will now be introduced into the cell, into the living host, or into the living cell. Okay? Oftentimes, in recombinant DNA technology, the living host is a bacterium. Okay? If it is not an E. coli, another common vector is the bacteriophage, which is a virus. Okay? So, di ba, may tanag chimeric DNA, di ba? Ano? So, ano po ang chimeric DNA? It is simply recombinant DNA molecule. So, an plasmid or an DNA nga may na foreign DNA inserted into it. So, the next step now is to put this chimeric DNA into the living cell or the living host. Okay? Ikakada na hiya, the plasmid, which is now a chimeric DNA, will now be introduced into the bacterium, into an E. coli. It can now be inserted or introduced into a bacteriophage if you don't want to use the E. coli. Okay? That is the 4th step in recombinant DNA technology. Isusulod mo na hiya. In a natural process, you can use transfection. Introducing the DNA or the chimeric nucleic acid, the chimeric DNA into the cells, into the bacterial cells, into the bacteriophages, which we commonly call as hosts or living hosts. Okay? Now, and iya ginsudlan and iya ginbutangan living organism man, this will continue to to multiply during binary fission. So when this living host will undergo division, this desired or this chimeric DNA will also multiply in number. Magdadamo liwat iya. Okay? Okay. So the next step is selection of cells containing chimeric DNA. Selection of cells containing chimeric DNA. Ipipiliin mo na ang mga cells na may ada DNA with the desired genes. Ang mga plasmids or ang mga living hosts na may ada chimeric DNA. Okay? Masarin ka naman, ma'am. Ma'am, isusugad la iton hiya. Di itong laboratory. No. Paano hiya mabubuhi itong living host? Definitely, ikakada mo ito niyan medium. I don't know if you still remember the process. An process, diba? Ginbubutang hiya medium. Ang didahan medium, amyada ko ganin Antoinette, Lavado. Do you still remember dito ha? Kasi kaya nagkamayada kami hini one-on-one discussion together with Giselle Banario. Dito ha laboratory, nga dagkuha kin Petri dish. Do you still remember that? So didan Petri dish, anay, mag-annotate kita. Didahan Petri dish, mag-annotate kita ha. So didahan Petri dish, kung ini ang Petri dish, Petri dish iton hiya. Glass iton hiya. Magklase nga ni, pakikita unta ko ng Petri dish kasi this is a common equipment in biology. So bubutangan iton hiya didahin food. Ang ginagamit nga food is agar. So remember this. Ginbubutangan hiyahin food. We call this agar as the medium food inihiya for the living hosts. Kami ada man food for these cells to survive, for this bacteria to survive, definitely magdadamo itong hiya. They will reproduce. Pag reproduce hini nga mga bacterial cells, chimeric DNA will increase in number. Meaning to say, the desired gene, kung usalaan imugin butang dida, usalaan imugin isolate nga gene, na one gene will now increase in number. It will multiply, magdadamo hiya. Okay? Selection of cells containing chimeric DNA is the fifth step. Paano mo i-select itong gene? Paano mo i-select itong gene? Kasi inihiya may ada ini chimeric DNA, adi chimeric DNA, adi chimeric DNA, adi chimeric DNA, adi diri chimeric DNA. How will you know? How will you know that DNA contains the desired gene? How will you know? Sige daw, hinunumdum pa. Ang nahinunumdum pa, han discussion. How will you know that that gene contains
Using
or that
antibiotic.
Very good. The use of antibiotic. So didahin nga plasmid, may ada dapat hito niya antibiotic na imo ibubutang. Okay, so pagbutang mo ang antibiotic, didahan medium, those plasmids without the antibiotic will definitely die. Meaning, ang mga survivors, they are the ones with the chimeric DNA, with the desired gene or the foreign gene inserted into the plasmid. Nakuha? Okay, so that is how you will select the chimeric DNA. Okay, so next step is expression of the gene to produce the desired product. Insertion of the gene to produce the desired product. Sigunta, karuyag mohin rose nga blue and color and flower. You will not put the desired gene directly into the rose plant. Maagi ka anay hininga mga steps, meaning after identification of the gene, after isolating the gene, ikakada mo anay hiya plasmid, meaning you will first form a chimeric DNA through transformation and then transfer the chimeric DNA into the bacterium or into the E. coli through transfection. Diri mo ididiretso ngadto rose plant. Kuha. Ipadadamuon mo naman iton hiya nga gene before you insert it into before you introduce it into the rose plant. Okay? So, clone amplification, isolation of proteins. So, once na-introduce na hiya into the rose plant using soil bacteria or using soil bacterium, or pwede mo na hiya i-insert ngadto ha, pwede mo na hiya i-insert ngadto ha, plant cell. Okay? So, padadamuon mo na ito. I-introduce mo na hiya into the rose plant and huhulaton mo na hiya nga dahiton pag-bear hiton flowers. Okay? Questions? Now, before we go to questions, I will let you see a video clip on recombinant DNA technology. Anay ha? Ma-insert na kita hin. Wait. Ano na to? Wait pa. Naya, ma-insert lang kita. Ma-share kita hin. Sana mag-break. Warahin niya sound, ha? Warahin niya sound. Nakikita niyo, class?
Opo.
Yes.
po.
Yes,
Opo.
Okay, very good. Dari tayo glue ha. Gagamiton iti da nga dari Elmer's glue gagamiton ha. Ginagamit iti da. That is the role now of the DNA ligase. Okay. transfection. We call that process of division as binary fission. That is the means of reproduction of bacteria. Okay. Hindi nagdamo na hiya. Okay, do you want me to repeat the video clip? Do you want me to repeat? Children? Do you want me to repeat the video clip?
Okay.
Okay na ito.
Yes po.
Yes, ma'am.
Okay.
Sige, i-repeat na.
Hello,
Before bacterium multiplies, magkukan ana iton hiya, multiply ana iton plasmid para equal iton hiya number when the bacterium divides. So mag-undergo anit hiyahin DNA replication before division of the host cell. Okay. So we will move to the nag-stop share ako ha. I will share another file. Ma-continue kita. Okay. So this time we'll move on to the activity. So one activity that you will submit on the next retrieval, pero pwede liwat if you are done. If you can do this right after the activity and you finish it at once, you can submit it anytime. So for the paper gene splicing, kasi damo na, ang ibahin ipinansubmit na nga diha akong kaya no daw lang agin balik. Okay. This is how you will do it. Di ba akintagan kamo hadi, hini? Di ba mayada hiniyo?
Yes.
Yes po.
Opo.
Kaya nga
Yes,
pinansubmit na, damo na tadi ha, kung pinansubmit na, ma-print na lang kamo hiton, ha? Nga, how? Pwede ba pinansubmit? May ikot ang pala. Okay. So, ini chromosome, ano? Ini. Tapos may ada hadid, di ba? May ada hadid, plasmid DNA. For this activity, you will actually do through simulation. You will do recombinant DNA technology using these materials. So mas maupaliwat kung mag-print lang ka mo kay colored. Colored iton magawa, colored inihiya. Kasi na akong ginhatag, makuan na ato hiya, black and white. Okay? So, the chromosome DNA in the material na-represent iton hiya. Coming from a human cell, a human DNA. So dida hini nga may ada perforated nga line. Dida niyo ikakat ang DNA. Ini ikakat niyo inihiya nga fragment of DNA. O ha, ikakat ini niyo ha. Cut inihiya nga portion. Just follow the instructions. Tapos, adi naman niya nga plasmid DNA from an E. coli bacteria, ikakatliwat iniya nga may ada perforation line or perforated line. Kakat ito niya, dida. Ano? Tapos, anon mo naman. Iniya igtatampo. Igkakoconnect ito niya. Uncut portion naman dida, inihiya nga cut portion ini i-insert mo into the plasmid. Okay?
Question po, ma'am.
Aha.
Sa mga mark, kita po yung mga anti-star, asya po dapat ito mag-join.
Adin hinay i-connect. Hinay-connect.
Okay.
Di ba, makakat naman itong hiya dida, ano, makakat, di magbubulag na itong hira. Ano? So, inihiya, di ba, nag-cut ka dida, i-connect mo hiya, dida. Ano? Dida, nanhit didi. Kaya di ba, dodoha din, dodoha itong ikakat nga portion, bali inihira, itatampo mo liwat yan. Pagdudurugtongon mo inihira. Pagdudurugtongon. Tapos ini nga mga cut portion, asa iton iyo i-connect, didihiton plasmid. Now, It nasa didit instruction. Dere nga yung pagtatarampuhon. Diditon instruction, magamit ka mohin parang bagi. Ang bagi nga iyo gagamiton, is a ziplock bag. Pwede luwat kung waray ziplock. Ayaw ko wag pinalit luwatin ziplock kung waray ziplock. Pwede ka mong gumamit yan. Itong nga ordinary lang nga cellophane. Basta just follow the procedure. So open the cellophane, equal waters, and remove the plasmid. Use the scissors to cut the plasmid as marked side. Let us be cutting along the dotted line. Just follow the. Actually, this activity is very simple. Basta itong karuyag ko nga mare-receive, naka-join na hiya. Akong karuyag mare-receive is a chimeric DNA, meaning plasmid hiya nga may ada na human DNA. Kukuha niyo plasmid hiya nga may ada na human DNA. Ano kay plasmid man hiya, ano ito ma-appear? Straight la hiya or circular? Circular. Definitely, magiging circular hiya. Kaya ipipaste mo man hiya. You can use, iton iyo pinakalay, guys. I think you can use Scotch tape. Gamit ka mo ng Scotch tape. Pag-join. Asat iyo pinakalay, guys. Nakukuha niyo?
Yes.
Yes po.
Pas niyo.
Kaya it glue?
Diri makakaya kay matatahuban itong G, matatahuban itong A. Palitan niyo gagamiton la Scotch tape. Bisan lagutil ang Scotch tape.
Tapos po mamit pagpas, kakadala namin cellophane.
Oo. Pwede kadalan cellophane or pwede liwat ikadalahin pwede kadalahin envelope, nga paper envelope. Anhi pa itong importante nga danay ninyo nalilikatan. Your name. Ayaw ak niyo patig akay bangit kan Raydel tapos din kadto ko kan Chad or kan Chad din kadto ko kan Raydel. Dapat may ada name, ha? Ayaw niyo nga limte kay I will not be able to record it if there is no name of the owner. Okay? Okay. So, after which, you will answer the questions here. Meron mga questions. Meron niya dida. Pipirahay lang questions. Guti lang yung questions. Meron niya question. Okay. Analysis questions. 1, 2, 3, 4. So 4 questions la. You will submit the answers to these questions together with your chimeric DNA. Nakuha? Nakuha niyo, children. Okay. So, we're not yet done, ha? Lesson 2 pala kita. Now, the next lesson is Lesson 3 is applications of rDNA technology. Applications. How is this rDNA technology applied? How is this applied? Or where is this technology applied? Actually, as what I've said on the first part of this discussion, applications of the rDNA technology is discussed in quarter 4. But since this is part of module 3, I will then be introducing to you the topics of quarter 4. The applications of modern biotech, the applications of recombinant DNA technology. Okay, so where can we apply this technology? Okay, so you can apply it to the field of medicine, the field of agriculture, to the field of you can apply this to the environment and to industry as well. Okay, now for food and agriculture, or for agriculture, production of food enzymes which are suitable in conditions for specified food processing. So RDNA technology can be applied in the food industry. You can apply rDNA technology in the production of enzymes that can get rid of bacteria that may cause spoilage to food. May ada kasi mga food nga masayon magpanos, masayon magraot. Now, in modern biotech or in genetic engineering, through recombinant DNA technology, you can make or you can produce enzymes that can get rid of bacteria that cause spoilage to food. Diba? Dako ito niyo nga kalugian in food industry, kung din itong mga restaurants, kung iton iyo pagkaon masayon magpanos. Okay? So that is one way on how rDNA technology can be applied. So it can be applied to food industry. In terms of agriculture, recombinant DNA technology is very, very important. Nowadays, dahil ng mga plantation. So nowadays, most farm owners do not already use chemical fertilizers or chemical pesticides. Instead, they use genetically modified soil bacteria to get rid of weeds, to get rid of pests. Okay. So instead of using artificial fertilizers or synthetic fertilizers, modern farm owners already use genetically modified or genetic modification in plants to produce nutritious fruits and vegetables. Plant resistant crops, or disease resistant crops, or disease resistant livestock. Okay, so again, rDNA technology is very, very important in the field of agriculture. So if you want to have healthy livestock, healthy plants, fruits and vegetables that contain more nutrients, genetic engineering is widely used and or widely applied. Okay. What else? Another application of recombinant DNA technology is on the health and diseases. Treating diseases and improving health conditions make use of recombinant DNA technology. Let's take, for example, gene therapy. So in gene therapy, this is using bacteriophages, modified or genetically engineered bacteriophages that can remove bad genes in human DNA. Bad genes are removed and healthy genes are inserted into it. In other words, the bad genes are replaced with healthy ones. That is gene therapy, which we will discuss in Q4. Okay, so another use of our DNA technology in the field of medicine or in the field of health and medicine is the production of antibiotics. The production of hormones like insulin. So nowadays, the reason why insulin is a bit cheaper now compared to the price during siguro na 1930s, compared to the price before, the price of insulin is quite cheaper now because they tapped the bacteria to produce the human insulin. Okay, so instead of humans producing insulin, nowadays bacteria can produce human insulin. And these human insulin from bacteria are now sold in the market at a cheaper price. Okay, so thank you, our DNA technology, for that. So aside from antibiotics, therapies, our DNA technology is also applied in the development of vaccines and yes, the recombinant hormones. So most of us are already injected with the COVID-19 virus. So these vaccines rather, so these COVID-19 vaccines are actually products of recombinant DNA technology. Okay, so kinuhahin gene or part of the COVID virus, tapos they put it into the meds and inserted into the human body, injected into the human body. Okay, so aside from the COVID-19 vaccines, the flu vaccine. The flu vaccine is also a product of recombinant DNA technology. Okay, so we also have, aside from the hormone insulin, we have another hormones, the LH and the FSH. I don't know if you are familiar with this. The luteinizing hormone and the follicle stimulating hormone. I think this is discussed in Science 4, Didahiton reproduction, human reproduction. You will encounter this when you go to grade 10. Okay, science 10 rather, so science 10. The luteinizing hormone, there are people that don't have the ability to produce this luteinizing hormone and follicle stimulating hormone. The reason why they are not capable of bearing a child. So yan na, these are already tapped in bacteria. So bacteria, aside from producing human insulin, they can also produce these hormones, the luteinizing and the follicle stimulating hormones. So in doing so, this is a big help in parents who don't have children. Okay, because the mother, the wife is not capable of producing the LH or the follicle stimulating hormone. Okay, so in the field of the environment, recombinant DNA technology can also be applied. In what way? Through bioremediation, bringing back the environment into its normal condition. We call it as bioremediation. So we remediate the condition of the environment using genetically modified plants, using genetically modified microorganisms. So these genetically modified plants or genetically modified microorganisms can help the environment get rid of toxic wastes, can help the environment get rid of toxic materials. Okay, so itong mga toxic wastes coming from mines, it can be removed using genetically modified microbes. There are actually microbes that feed on toxic wastes. There are microbes that feed on oil. So using these microorganisms, padadamuon iton hira, an irrigene that can degrade oil can be inserted into other microorganisms to help improve the environment, to help bring back the environment into its normal state. And we call that process as bioremediation. So, munta nagkakamay ada oil spill. Oil spill kunta dito kadagatan wherein sigunta may ada nag-shipwreck tapos adto nga ship adto nga cargo ship na darahiyahin mga oil tanker kunta adto hiya nga ship nga nag-shipwreck. So kay dito man nakadagatan nag-shipwreck, siyempre an oil malalagas dida hadagat, killing marine life. Okay? So itong bubuhaton hiton mga scientists, bubuhaton hiton mga technologists, they will tap microorganisms that feed on oil using recombinant DNA technology to get rid of these toxic oils in the ocean. Okay? To save the environment, to save marine life. Okay? So another in the field of industry, aside from the food technology that I have mentioned just a while ago, we can also use recombinant DNA technology, or we can also apply recombinant DNA technology in the production of biofuels. Okay, yan na nga natin kamahal iton oil, natin kamahal iton gasolina. I remember when I went to Vizca a few years ago, may ada dito kurso, I think it was systematics, parang agricultural engineering nga nahimuhirahin biofuel. I think it was in Vizca. Nahimuhiran biofuel, a fuel alternative. Instead of using gasoline, they use they manipulate plants to produce fuel. Okay, so that is all about applications of our DNA technology, which is in lesson 3. Now, in lesson 2, if there is an activity for this, lesson 3 also has an activity. Lahain itong hiyang activity. Okay, let's apply what you've learned. This will be the other activity that you will pass on the day of retrieval. Pero kung human ka na, you can pass it in advance. Kadto la school, ibutang la dito hiton box. Itong kanang biotech box sa Science Hub. Just answer all the questions here. I think this is 1 to 8 questions. There are 8 questions that you will answer. Okay, so questions on quarter 3, module 3. Questions?
No.
Feel free to ask.
Ma'am, kailangan pa po ba video hit gene splicing?
Diri na. Kay masabit naman kamo henhan kuan, actual nga output. Kailangan kun actual nga output ha. Diri la picture, actual nga output.
Excuse me, ma'am.
Yes.
Waray po pakasaladi ni Ramirez kaya naglukodawan niya gadget.
Okay, hala. Sumati na la niyo ha. Ito na akong gina-require.
Okay po.
Thank you. Ano pa? Ano pa? Ig-on la, Gregor. Ig-on lang, di ikatula dito. Okay, are there still questions on the discussion and the activities that you will submit? So this will be the last discussion that we will have in quarter 3 kasi 3 modules lang kasi hiya. Wala nak mag-discuss ang module 2 kay kaya niyo ato basahon.
Ma'am,
Yes.
pina po nga applications of our DNA technology. Pud yan ibahan required activities. Yan ang-
Opo, yes. Opo ditong hiya. Oo, opo ditong hiya. I think nakada itong hiya last and required. Parang I will only require you to pass 5 outputs. 5 ba? 1, 2, 2 in module 1.
6.
6 tanan, tagduha-duha.
Yes. 2 in module
Okay.
1, 2 module 2.
2 in module 3. Okay. Ay, oo, duha kay module 2 kuan concept map and graphic organizer.
6 po.
Tapos ang module 3, gene splicing and applications. Application of RDNA. May napapakian na. Tomorrow, by the way, the schedule for assessment or summative test will be at 8. 8 o'clock. Ano? Nagmamata na kamo ito na, no? 8 o'clock. Tapos itong 4th, face-to-face na kita. Tanan ba kamo willing? Mag face-to-face classes?
Opo.
Still contemplating po, ma'am.
Yes.
Opo,
Yes,
very willing.
Iton diri ma-join, iton face-to-face, diri na kita mag-go online, ha? Wari ko na online, kaya ato na kita eskwelahan. Wari na iton online class. Maglilinog ka rin kapag answer it module. Okay na. Okay na, children. There might be applications of rDNA technology that were not mentioned during my discussion. Basahan na lang hiya dida. Anyway, production of transgenic plants. Sumira nga na transgenic. Ano pa to? Transgenic. Transgene. Trans means transfer. Genic from the word gene. So there is a transferred gene in that organism. Meaning there is a foreign gene in that organism. So tawag naman itong transgenic. Kung plant here, transgenic plant. Kung animal, transgenic animal. Okay? So production of hormones, vaccines, interferon. Okay, so antibiotics, production of commercially imported chemicals, enzyme engineering, diagnosis and okay. So basahan na lang niyo. Anyway, kaya akong gin-add and waray okay. So nag-add la ako din. Okay? So we'll check the attendance again. Check ko nga ha. Ada na ka mo. Bangin nasulod pala ka mo yan ha. Quarter 3 and quarter 3. Okay. From section Mango, Apita, Zion, Araba, Mark,
Present.
Chad,
Present.
John David, Justin Lay,
Present.
Lance, Dick, Juno, Ernst, Bon, Eugenio, the fourth, Christian, Andre,
Present.
Alexi, Emmanuel,
Present.
Jade, Carl Vincent, Panis, Yeshiel, Cesar, San Emmanuel,
Present.
San, Marie Vincent, Erica Marie,
Present.
Lorraine Abobo, Zoe Afable,
Present.
Gail Alde,
Present po, ma'am.
Anna, Gia Ambil, Raven
Present.
Rose, Joyce Gail. So Raven Rose is present. Siya? Raven Rose? Anna adto ang nagsaring present? Anna Gia?
Opo.
Okay, Raven Rose. Waray. Joyce Ampong, Julia Apura.
Present.
Nash Astakaan. Nash? Ay, Nash. Nakanamat kanina. Colima Angeline.
Present.
Jan Antoinette, Dr.
Present.
Krishna Jamel.
Present po, ma'am.
Jeslaine. Jolola.
Present po, ma'am.
Jeslaine. Aliana Docena.
Present po.
Jillian Gapate. Jillian. Waray Jillian. Julia Alexis Guevara.
Present po, ma'am.
Antoinette Labado.
Present.
Maxian Marasigan.
Present.
Debbie Menzon.
Present po, ma'am.
Angel Monroy. Isabella Peralta.
Present, ma'am.
Francesca Promeda. Jaslyn Puno. Angelic Suwal. Okay, so we go to section Santol. Joshua Abusejo. Anyosa?
Present.
Okay, Joseph. John Edward. John Edward. Kindly turn on the camera. Bulanadi, Mark, Kenneth.
Present.
Earl Joseph.
Present.
Earl Dilantar.
Present.
Andre Labro. Renz Rodolph. Lilia.
Present, ma'am.
Hans Lomar Rosalejos. Radel Trabaco.
Present.
John Ray. Radel Samson. Present.
Present po, ma'am.
John Ray Trabaco. John Ray. Okay. Princess Abelia. Kera Adamas.
Present.
Kera. Francine Alaya.
Present.
Hannah Amos. Hannah.
Present.
Denise Apura.
Present.
Giselle. Present Denise. Denise Apura. Denise absent. Giselle Pay.
Present.
Andrea Beato. Andrea. Miska Cepeda. Kiana Sisista.
Present po.
Kiana ito ano?
Present po.
Jazzy. Marian Dulfo. Marian. Cristel. Factor. Denisa. Hyacinth. Galupe. Tricia. Garcia Angel. Liana Gura. Liana.
Present.
Hazel. Hilaria. Hazel. Shira. Habuli.
Present po.
Charnet Latoha.
Present.
Giselle Mendoza. Jahara Montes. Jazil Padilla. Jazil. Isaiah Pagayanan.
Present po.
Isaiah, okay. Alison Pan. Yeza Puno. Ninia. Cherise Ridiang. Grace Love Sabido.
Present, ma'am.
Ella Turla.
Present po.
Okay. So that ends our quarter 3 lessons. Wait lang. Kindly turn on the camera. Kay igko ko ang kala magsisend like in picture. Please turn on the camera. Please turn on the camera. Okay, Aliana Docena, please turn on the camera. Okay, thank you. So we go to page 2. Please turn on the camera. Okay, so thank you for bearing with me. Tomorrow we'll have the summative test via Google Classroom. Now, for the summative test, please expect true or false questions. True or false statements, rather. True or false statements. Where you will, I will be making statements that you will analyze. Okay, so thank you and bye. Bye, class.
Bye, ma'am.
Bye, ma'am. Thank
Bye,
you.
ma'am.
Bye.
Bye.
Bye, ma'am.
Bye-bye. By the way, anwaray pa magpasan kuan anwaray pa magpasan restriction enzyme and other activities in quarter 3. You pass it together with module 3 activities. Okay, bye.